Welcome, everyone, to this exploration of artificial general intelligence. Today, we will discuss its definitions, ongoing debates, and the challenges. This journey holds key insights for aspiring minds like yours, as the pursuit of AGI may redefine the way we live and think. AGI is at the center of innovation, and several leading companies are chasing this goal. OpenAI, in collaboration with Microsoft and SoftBank, is forging ahead. Similarly, Google DeepMind ambitiously aims to achieve AGI within the next decade. Other contenders include Anthropic, focusing on AGI safety and interpretability, and IBM, which applies its Watson system for cognitive computing. Additionally, Microsoft empowers this pursuit with robust infrastructure like Azure. Meanwhile, China's DeepSeek is making waves with its open-source reasoning model DeepSeek R1, demonstrating competitive AGI potential. But what is AGI? AGI is the abbreviation for Artificial General Intelligence, a form of superintelligence that can go beyond the confinement of a particular task. While today's AI can perform highly specialized tasks with superhuman precision, from playing Go to recognizing faces, it lacks the flexibility of human intelligence. But what exactly do we mean when we talk about AGI? And why do some experts believe we may never achieve them? Most AI systems today fall into the category of narrow AI, meaning they are designed to excel at a single task, but cannot transfer that expertise to other domains. For example, an AI that can defeat the world's best Go players cannot suddenly become an expert in speech recognition or medical diagnosis. Artificial General Intelligence, AGI, on the other hand, refers to AI that can perform a wide range of cognitive tasks at human-like levels, demonstrating flexibility and adaptability across different domains. If an AI system could not only play chess, but also drive a car, compose music, conduct scientific research, and hold meaningful conversations, all without being explicitly programmed for each task, it would qualify as AGI. Going a step further, strong AI is an AI that possesses not just intelligence but also self-awareness and consciousness, making it indistinguishable from the human mind. Sci-fi characters like HAL 9000 from 2001, A Space Odyssey, Commander Data from Star Trek, and Skynet from Terminator are prime examples of what strong AI could look like. However, in most discussions, AGI and strong AI are often used interchangeably, though some scholars draw distinctions based on different criteria. When we want to make machines that can mimic human intelligence, we need to define intelligence first. The definition of AGI depends on the perspective one takes. Computer scientists typically define intelligence in terms of goal achievement. By this measure, an AI qualifies as AGI if it can perform a broad range of intellectual tasks effectively. Psychologists bring in the human adaptability perspective. For them, human-like intelligence is about thriving in diverse contexts, adjusting flexibly and mimicking the human brain's cognitive adaptability. Philosophers, such as John Searle, have introduced the concept of consciousness into the discussion. According to Searle, an AI can only be considered strong if it possesses self-awareness, not just the ability to simulate intelligent behavior. Some theories of intelligence incorporate Howard Gardner's theory of multiple intelligences, which include logical mathematical, linguistic, spatial, musical, kinesthetic, interpersonal, intrapersonal, and naturalistic intelligence. A strong AI system, by this definition, would need to demonstrate all of these. From this perspective, AGI does not necessarily imply strong AI. An AI system might achieve AGI, performing an extensive range of tasks, but still lack consciousness, making it functionally powerful yet philosophically weak. Scholars are divided on AGI's feasibility. Despite advancements, many believe that reaching human-like thought and understanding may be beyond machine capacities. Philosopher Hubert Dreyfus saw human cognition as largely unconscious and context-driven, making it hard for AI to replicate. AI's reliance on algorithms further limits its ability to handle sarcasm, emotion, or nuanced scenarios. John Searle's famous Chinese room thought experiment reinforced this skepticism. He imagined himself in a locked room, receiving Chinese characters and using a rulebook to respond in seemingly fluent Chinese, despite having no understanding of the language. This, he argued, is how AI operates. It manipulates symbols without true comprehension. Another critique comes from cognitive scientist Gary Marcus, a strong opponent of deep learning as a pathway to AGI. He echoes both Dreyfus and Searle, arguing that AI thrives in structured, rule-based environments, but struggles in unpredictable, real-world situations. For instance, a computer vision system once misidentified a sticker-covered parking sign as a refrigerator stocked with food, an error no human would make. Marcus also draws on social psychology, particularly the fundamental attribution error, to explain why people overestimate AI's intelligence. This cognitive bias leads humans to mistakenly attribute deep understanding to AI when, in reality, it is simply generating outputs based on statistical patterns. A classic example is Eliza, an early chatbot that convinced users it understood them simply by outputting empathetic-sounding phrases. Indeed, today users interact with AI chatbots, like ChatGPT and Claude, also mistakenly perceive that they are conscious. A friend of mine even said ChatGPT is her boyfriend. So, what's holding AI back from achieving AGI or strong AI? Marcus and his colleagues, drawing inspiration from psychologists Steven Pinker and Elizabeth Spelke, argue that current AI systems lack key components essential for true intelligence. 1. AGI compositional structure. The ability to combine simple concepts into more complex ideas. 2. Common sense reasoning. Understanding the world in a way that humans take for granted. 3. Knowledge representation. The ability to store, organize, and apply knowledge efficiently. 4. Innate cognitive machinery. The inborn mechanisms that guide human learning from infancy. Without these, Marcus contends, AI will remain a powerful but fundamentally limited tool rather than a true artificial mind. The solution proposed by Marcus is a more interdisciplinary approach that integrates insights from cognitive science, linguistics, and philosophy, rather than relying solely on deep learning. The content of this video is based on my article, Artificial Intelligence, Machine Learning, and Psychology, published in Oxford Bibliographies. The link to the article can be found at the description of the video. The dream of AGI and strong AI continues to captivate scientists, engineers, and philosophers alike. While AI has made incredible strides, it remains fundamentally different from human intelligence in key ways. Whether we will one day build a machine that can think, reason, adapt, and transfer learning like a human, or even possess consciousness, remains an open question. What is clear, however, is that AI research is far from reaching its final frontier. Whether through new algorithms, interdisciplinary breakthroughs, or radical new theories of intelligence, the quest for AGI is one of the most fascinating challenges of our time. The future of AI is still unwritten, and perhaps the biggest question isn't, can we create AGI? But rather, should we? What are your thoughts? I'd love to hear your perspective. Please share your thoughts in the comments below.